week 8. This is the final week for the course Embedded System Design with ARM. In this week, we will be discussing about accelerometer and some of the experiments that we can do with this device. So, essentially in the first lecture, which is this lecture, lecture 38, I will be discussing about accelerometer, what it is and what is the principal operation of this accelerometer. Then in the subsequent next two lectures, I will first discuss that how we can interface an accelerometer with the STM board and how we can receive the data. This is the first thing that I will show, and then I will show you some experiment where the orientation of the device, we will find out what is the orientation of the device, whether the device is lying flat or it is vertically up or it is vertically down, etc., etc. So, these are the few things that we will be looking into with respect to accelerometer, and there is one more thing that we will look into in this week is with gas sensor, an experiment with a gas sensor. So, let me talk about this accelerometer. In this particular lecture, I will be discussing the principle of operation of accelerometer, and the accelerometer that I will be discussing, the features of the accelerometer that I will be discussing is ADXL 335 accelerometer. So, what is an accelerometer? It is defined as a dynamic sensor that can measure acceleration in 1, 2 or 3 orthogonal axes, that is x, y and z. And typically it is used in one of the three modes. It can be used as an inertial measurement of velocity and position. It can be also used as a sensor of inclination, tilt or orientation in 2 to 3 dimensions, or it can also used as a vibration or impact sensor, shock sensor that we say. Most of these accelerometers that are developed, the devices that are developed are based on micro electromechanical sensors called MEMS. So, it is based on this technology, and this is based on displacement of a small mass that is etched into the silicon surface of the IC and suspended by small beams. So, we will look into further when we display the working principle, when we show the diagram, it will be more clear. So, as an acceleration is applied, a force is developed. We know that P equals to mass into acceleration that displaces the mass. So, this is the general concept of acceleration. The displacement of the mass can be measured using capacitive sensing or piezoelectric effect sensing. So, these displacement of this mass, when it is moved from one point to another, it can be measured using either capacitive sensing or through piezoelectric effect sensing. So, what it happens basically, there is a change in capacitance or there is a generation of voltage through which it is measured. The basic structure of the accelerometer consists of a fixed plate and a moving plate, and the acceleration deflects the moving mass and unbalances the differential capacitor that results in a sensor output voltage amplitude which is proportional to the acceleration. What does it mean? Basically, there is a moving mass. Okay. So, this when acceleration some acceleration is made, then this deflects the moving mass and unbalances the differential capacitor. Okay. So, then in the two parts we will see that the moving mass in one part it will come to the other side, and the other part it will come little more to the other side. So, there is a imbalance in the mass. So, by measuring the acceleration along the x, y and z direction, it is possible to calculate the inclination or the tilt. So, how much it is tilted, okay, we can accurately find out using the accelerometer. So, this can be done by measuring the acceleration along the x, y and z direction. It is also possible to calculate the angles of rotation along x, y and z axes, which is called, if it is along x axis it is called a roll, if it is along y axis it is called the pitch, and if it is z axis it is the yaw. Okay. Now, this is like this. Here we have these fixed plate. Okay. So, here if you see we have fixed plate, this one, and this here we have the moving mass, and you see that whenever there is an acceleration this changes. So, this particular yellow thing which is there, it changes. Okay. So, based on which we can accurately find out whether it is tilted more towards x direction or y or z direction. Okay. So, this is the accelerometer sensor with MEMS mechanism. Now, the accelerometer that we will be using in this experiment is ADXL 335 accelerometer, where you can see that these are the pins of this accelerometer. Basically, you have this VCC, we have this ground, and we have x, y and z coordinate. So, this is from the other side, and this is from the other one. So, this arrow shows the x axis, this arrow shows the y direction, and this one is the z direction. Okay. So, the ADXL 335 is a small, thin and low power 3-axis accelerometer with signal conditioned voltage output. What it can do basically, it can measure the static acceleration due to gravity in tilt sensing applications, as well as dynamic acceleration resulting from motion, shock or vibration. Okay. This we already discussed. So, this accelerometer can will be able to access, I mean we can get the acceleration using this accelerometer due to gravity for applications as well as for dynamic acceleration resulting from motion, shock and vibration. This module measures acceleration within the range of plus minus 3g in the x, y and z axes. When we connect this with STM, we will be seeing that we are mostly concerned about this x out, y out and z out. So, what essentially we have to do here? When we will connect, we will be connecting these x out, y out and z out to the analog port. Okay. So, the output signals of these are nothing but some analog signals. So, these are some analog voltages that are proportional to the acceleration. Okay. Now, the interfacing, if you see, which is fairly very straightforward, we have shown it using Arduino. We have done the experiment using STM when we show you next. So, this is where it is connected to BCC. This is connected to ground, and this X, Y and Z is connected to pin A1, A2, A3 depending on where you connect. You can also connect to A0, A1 and A2. So, this is a very straightforward connection diagram that we have. So, X out, Y out and this will be X out, Y out and Z out are connected to the analog input pins. Okay. So, this is all about this device accelerometer. So, next we will look into how we can connect this accelerometer with STM board. We have already shown you the connection. So, how we can connect this, and we will see that what value changes, what we get, what kind of values we receive from this accelerometer from the x axis, y axis and z axis. So, we will look into that in the next lecture. Thank you.